about this, where are the hot spots? Okay, as we go across, they get smaller. And if I start veering down at all, they get bigger, which means that's a hot spot. These are the smallest guys of all. So that's a hot spot for being small. Okay, here's your other hot spot. If we go down, we're getting bigger. If I veer to the right, we start decreasing. So this is the hot spot for big. Okay, we're ready for level 3, and this is a question. And it's problem 5-1 in your chapter. And it says you have cesium, fluorine, potassium, and chlorine. And the question is, and why don't I put it up here so you can actually see the wording. And let's look just at 5-1. Okay, let's look at the wording there. If this were an easy question or a nice question, they would just say, of those 4, who's the biggest of them all? Or, who's the smallest of them all? What is the worst case scenario? Having to rank them all. And here's a problem area on test day when you're kind of keyed up and nervous and not reading as well as you normally read. We want to put these, and the wording here is in increasing order of atomic radii. Okay, and that translates as smallest to largest. Now, I could say decreasing order, but this particular problem says increasing order. And I can't tell you how many times on test day people get it just backwards. So we want to go, when you say order of increasing size, we want to go smallest to largest. Here is a trick. This is such a wonderful trick. If you've got a bunch of them to rank, I had trouble. If I were to look at that periodic table and say, I'm interested in cesium, fluorine, potassium, and chlorine, to look up there and look at those 4 and keep track where they are and block the other 100 out of my brain. I have trouble doing that. If you can do it, more power to you. But here's what I do. I rewrite these in their relative positions in the periodic table. And so I look up there and I find cesium. So I say, okay, cesium is in the lower left. Then I say, well, this potassium is a couple of places above it. And then I say, well, fluorine is way over here. And then chlorine is below it. And so here's my relative periodic table, where I've left out everything I'm not interested in. Okay, where's my smallest area of all?
Fluorine.
Fluorine. Here's what I do. I start at the hot spot, in this case for the smallest. I just snake my way down to there. Okay, now I know some of your brains are going, what if, what if, what if? If you have a question like this and it says rank a bunch of them, the snake will work. Okay, there's not going to be some that are so closely together, this won't work. So, yeah, I could come up with some god-awful problem where the snake would not work. But you will have, there are going to be distinctly enough areas here you can do it. So, you start at the hot spot for the small ones, because remember, we translated increasing order to mean smallest to largest. So, who's the smallest of them all?
Fluorine.
Fluorine. Okay, who comes in next?
Chlorine.
Chlorine. Who comes in next? Potassium. Who comes in dead last?
Cesium.
Cesium or largest. Be sure you got these guys straight. You know, less than, greater than business. Again, that's another big place when you're keyed up and anxious, you screw up on those signs. So less than. See, when you think about this, this is the smaller opening. I mean, there is no opening. That's your big opening. So we're going small to big. Okay, we are right on that one. So One more time. 3 levels. Level 1, know your arrows. Level 2, it'd be nice to understand why the arrows are as they are. Level 3 is where you earn your points, like that. I give you some, and you tell me. You either rank them, or sometimes, if I'm feeling nice, I just say, who's the smallest of them all? Well, that's easy. Then you don't have to do that. If I say, who's the smallest of them all on those 4, who's closest to that hot spot? And we usually leave the noble gases out of these questions. So 4 is the smallest of them all. Who's the largest of them all? Look for the hot spot. Who's closest to the hot spot? Cesium. But if you have to rank them, that's when that comes in handy. Okay, now, let me come over here, kind of a summary. And this is for trend 1, atomic radii, decrease, increase. And when you're looking at these arrow systems, if you choose to use my arrow systems, if you can remember one of these, the other is the opposite. Always, always, always. This one's, I think, the easier to understand. You're going to increase in size as you go down, because first level, second level, third level. So this one's easy. You think, hey, I can't remember the other, but I know it's the opposite. All right, next one. The next trend we're going to look at is what is called ionization energy. Okay, I hate this word, because if you just saw that, or if I just saw that for the first time, and I would try to crack the code and make sense of this without looking it up in the book, I would say, it must be the energy it takes to make any old ion. And that would be wrong, because the way they have defined it is this. Let's start with some neutral element. I'm going to call it M. Usually metals do this. Okay, I'm going to call it M. To rip off an electron or steal an electron, it's going to cost you energy. The energy it costs you to make a cation. This term is only for cations. It's not energy to make anions. It's cations only. That's why I don't like the word. I think it's misleading. Okay, this is referred to as the first ionization energy. You actually have an energy measurement. You got this neutral atom, minding its own business. You zap it with some energy. How much did it cost you to rip off an electron? Now you realize we have things other than +1 cations. So we can take this on. I can take that +1 cation. I can put in some more energy and make the +2. And this is referred to as the second ionization energy. And then one more time, I can take that +2 cation, put in some more energy, and rip off a third. Here's something for those of you that have had a lot of science in your background and you heavy-duty thinkers. Sometimes people write this a slightly different way. Let me just show you, and then I'm going to erase it. For this one right here, sometimes you see it as M minus 1 electron to form the cation. This is correct also, but it's just a different format, and I do not like this. If you think about an arrow, it's very similar to equal signs in a math equation. You know you can move things to the other side, and if you've added it on this side, if you move it to the other, then you subtract it. The reason I don't like this, and I'm not going to use it, because I like to emphasize you get not only this cation, you get an electron as a product that you get to go use someplace else later on. And so I like it this way. Okay, so we have first, second, and third ionization energy, and we go no higher than that. Do you recall back at the very first of the semester, we talked about what cations form and who does it? And we look up there, and I said +1, +2, +3. And I said way back then, probably in late August, I said we don't go higher than +3 normally because it simply costs too much energy. Now anything is possible in chemistry. You could steal all of its electrons if you had sufficient energy. But we usually routinely steal 1, steal 2, steal 3, and then it starts to cost us too much. One thing, here's a trend I want you to know, is the third ionization energy is always greater than the second ionization energy, and that is always greater than the first. Okay, doesn't that make sense? It's going to cost you more to steal the second one than the first one. Let me give you an example to help you remember that idea. Okay, let's say today I have discovered I don't have any lunch money. Okay, so I'm going to hit up Marco. He looks like an easy touch here. I say to him, would you loan me, and I use the word loan, would you loan me $5 for my lunch, because I just forgot to get it and I don't have any money with me to run over to the student center. So he thinks about it briefly, because after all, I'm his teacher and I have said I'll pay him back. Okay, so he's going to loan me the $5. Okay, let's say on Thursday, I still don't have any money, and I come over to Marco again and see I'm not paying him back. I'm saying, you know, I forgot my purse again. I don't have any money today. Okay, well, I probably have to work harder this time. I got to have a better story than just, oh, I left my purse at home, or I don't have any money, or whatever. I got to say, oh, my children didn't have money for lunch this morning, and they took the last of my money, whatever. And I have to tell a longer story and use a little more energy to talk him out of a second $5. Okay, how about next Tuesday? Okay, I still don't have any money. I go up to Marco, and I still haven't paid him back. And I go, Marco, are you good for another $5? But I got to have a real story now. I got to say things like, my husband beats me, he doesn't give me money. You know, I've got HIV and I'm 3 months pregnant. And he's never going to believe this story. But I got to work really, really hard, you know, to get that $35 out of him. Okay, that's the way the elements are here. Hey, talk him into it once. Not a big deal, cost me a little bit of energy and time. Hey, I might be able to pull it off a second time, but by the third time around, he's wise to me, and I've got to tell a really good story, okay, to ever get that third one. So it costs more energy.